page called How Stuff Works, where you can see many interesting things. Among them, how you implode buildings. Now, the first thing to do is to get the architectural blueprints, of course. And next, what people do nowadays, they develop three-dimensional models, mathematical models of the building, not only to determine where the loads are and the strengths of the components, but also they can put in charges in this model to see what the consequences of the explosions will be. But it is not only a matter of mathematics and computers, it's also an art very much based on intuition. So the experienced blaster go through the buildings many times and make their decisions. Like taking over a building, like the last demolitions I showed you before, is not considered anything, or pulling over a chimney, just like felling a tree. It's not considered with any respect. But to hit the footprint requires a skill that is only less than a handful of companies in the world who actually can accomplish such a feat. Now, in order to demolish buildings, you need some tools. These are explosives. Now we're getting into the explosive business. Dynamite is an old-fashioned and well-known material, and it's very good for concrete. It's slow. You bore a hole and you light your fuse, roughly. But if you want to take down steel beams, you need something more sophisticated and modern. The most common thing for this purpose is the stuff abbreviated RDX. Why it's called that, I don't mean. But here's the structure of such an explosive we call cyclotrimethylene trinitramine. Now this is really nasty stuff. The burn rate is running at a speed about 23 times the speed of sound. So actually the explosion wave breaks the sound barrier that many times. So this is really something which hurts the ears. And here you see they come in something formulating called beam cutters. And here you see such two demolition workers mounting two beam cutters on each side of such a steel beam. And an explosive works by force, by pressure. It knocks the thing over like that. So what obviously the reason for mounting it at this angle is that the weight of the beam should make it slide down, and they can have consecutive beams here, all triggered at the same time, so the whole building actually moves aside and then go down. And then somebody have found it remarkable that some of the steel beams appearing at ground zero after the collapse of the towers, I don't know about Building-7 at this point, this is from the towers, was cut at the same angle actually. And there's been some dispute about this picture as to which time it was taken, but these are firemen going, and they're looking for, sadly, they're looking for the remains of their colleagues. And this they were allowed to do up until September 29th. So it must be a fairly early picture. Now, I'm going to show you, regarding explosives, a video by a physicist called David Chandler, the same guy who did the calculation on the tower. And this is, I would say, it's self-explanatory. And what you'll see here is taking the sequence of the collapse of the North Tower and recycling it.
The starting point in science is observation. What you are seeing here is what happened to the North Tower of the World Trade Center, the second of three buildings to collapse on 9/11/2001. I use the word collapse, but words can be deceptive. What do you really see happening here? There's a tremendous amount of falling debris. Under the canopy of debris, you see the rapid sequence of explosive ejections of material. Some of the jets have been clocked over 100 miles per hour. I will call them explosions because it's hard to find other words to describe what we are seeing here. The explosions are not isolated and deep. They're continuous and widespread. They move progressively down the faces of the building. keeping pace with the falling debris. Perhaps you can imagine a natural cause, but I can't. Notice that the explosions are occurring on multiple floors at once, over a wide zone, not in a floor-by-floor sequence that might be explained by pancaking collapse. Notice there are explosions far below the point of collapse. Some are isolated and focused. These are often referred to as squibs and are commonly seen in controlled demolitions. However, this is not a standard controlled demolition. The building is being progressively destroyed from the top down by waves of explosions, creating a huge debris field. The destruction is in waves, not just in one wave. Most obvious is a rapid sequence of explosions near the visible corner of the building. But simultaneously, we can see another wave of explosions much further down the face of the building under the canopy of falling debris. Notice that both waves of explosions progress down the face of the building, nearly keeping pace with the falling debris just a few feet away. Slabs of concrete did not fall to the ground and smash to dust. There was almost no concrete in the rubble pile. Notice that the concrete is being forcefully ejected outward from the sides of the building, already pulverized to dust. Notice that embedded in the dust clouds are huge girders and entire sections of steel framing that are being hurled out of the building. The horizontal speed of some of the girders has been clocked over 70 miles per hour. Some of these girders impale themselves in the sides of neighboring buildings. Some landed as much as 2 football fields away from the base of the tower. What could hurl heavy girders with such force and give them such speed? Some people have suggested that the weight of the tower crushing down on the girders caused them to flex, and they sprung sideways by a spring action. But we are not seeing isolated jumping girders. We are seeing a major fraction of the mass of the building, steel, concrete, office furniture, and the remains of human beings, reduced to small pieces of rubble and fine dust, and being explosively ejected in all directions. Bone fragments are found on the roofs of adjacent buildings. The bones were not crushed in the falling mass, or they would have been trapped in the debris pile. They were pulverized along with everything else and blown out in all directions. The NIST investigators have claimed that the top section of the building, above the plane impact point, came down like a pile driver, crushing the undamaged lower section of the building all the way to the ground. The top section of the building is, however, noticeably absent. There is nothing above the ring of explosions except for a fountain of debris. Can you see a pile driver?
Okay, I stop it here. I think this is, when you're seeing this video, there's no question left, in my mind at least, that explosives were used. Here you see the steel beams from 2 to 30 tons were thrown 100 meters away. And I don't know the exact weight of this one, but this is not a spring action of the steel beam. These are explosives. But there were other observations also done around the towers. So I'll show you here a picture from World Trade Center, the South Tower. This is around the 82nd floor, I think, where something is pouring out of the corner of the building. The South Tower is the 82nd floor, yeah, around that, yeah. And the point is that this is red-orange, what's coming out here. This is seconds before the collapse. Half a minute before the collapse of the South Tower. You have a strange observation. This is another video. There's no doubt that there is something going on, unusual going on here. And even NIST recognized that this has an orange glow, whatever came out of the South Tower. Which means that it is not aluminum. Molten aluminum is white, like silver. It melts at 660 degrees, depending on the alloy. And so it might easily actually melt at an ordinary office fire. But this can only be iron, molten iron. This is the only metal which can account for this observation. And iron melts at 1538 degrees centigrade. And there is no way this temperature can be reached in an ordinary fire. If you have a stove at home or a an old-fashioned stove, or you use it for burning wood.